Hello, I'm Mohammed, a PhD candidate at the University of Toronto. Welcome to my video lecture. In this lecture, I'll be covering the basics of errors in hypothesis testing. And I'll also go through step-by-step solution process of an actual exam question. So let's begin. This is an actual final exam questions at the University of Toronto. So the question says a particular variable x follows a normal distribution with mean mu and variance 225. We are given the null hypothesis states the population mean is 225 and the alternative one-sided hypothesis that states mu is greater than 225. So a random sample of size n equals to 36 from the population has been collected, and we have observed that the sample mean is 228. So given this information and based on the sample, the question 1 says, should we reject the null hypothesis? Okay, so at this stage, I'll consider that you have the basic understanding of how to solve part 1 of the question. So I'll skip the theoretical part, I'll go straight to the solution. So what we will do, we'll do a 4-step solution in this case. Step 1 will be stating the hypothesis. In our case, it's given explicitly in the question, and it says the null, it says mean is 225 and alternate is greater than 225. Now, step 2. With step 2, we have to compute the test statistic. So the general formula for test statistic is estimated value from the sample minus hypothesis value in the null divided by standard error of the estimator. So in our case, we will be calculating the z value and it would be x bar minus mu h naught divided by standard error of x bar. So from our given information, x bar is 228 minus 225 and standard error of x bar would be the variance of 225. We are given the variance is also 225 divided by sample size, which is 36, and then square root it and we get the standard error of x bar. So from this we get that the z value is 1.2. So step 2 is done. Now step 3. So we have to find the p-value. So now in this step 3, there are different ways you can, the very basic one and the core concept is you have to find the p-value. Alternatively, you know that you can compare your z value, the test statistic that you got in step 2 with the critical values, or you can formulate the confidence interval and then check whether the null value is within the confidence interval or not. But I'll be covering the basic one. So we'll be computing the p-value, and because we are doing a right side test, mu is greater than 225. So in our case, we have to calculate the probability of z being, what if we got 1.2, so we have to calculate what the probability is of z being greater than 1.2. So now we know z is symmetric, so probability of z being greater than 1.2 is probability of z being less than minus 1.2. Usually in the z table, you always get left side area on the left. So from the z table, you will find that this value is 0.1151. And in the question, we were asked to do the hypothesis testing at significance level 0.05. And our p-value, we got 0.11, that is greater than 0.05. So now it's the decision time. In step 4, because our p-value is greater than 0.05, we state that we fail to reject the null hypothesis at 5% significance level. Right? So that's a solution for question 1, and you follow this 4-step all the time and you get 100% mark for this solution. Okay, so now let's look at the question again. In question 2, it says, say the true value of mu is 232. So the null is not correct. Okay, true value is 232. Had the sample size been n equals to 881, would we have been more likely to obtain x bar is greater than 228? So this part of the question has nothing to do with hypothesis testing. It's simply from law of large number. So from law of large number, we know higher the sample size, the closer we will be to the population mean, right? So in previously we had 36 and we got 228, and if the actual true value is 232, if we increase the sample size, we should get closer to the mean. So that means yes, we would be more likely to get x bar that is greater than 228. Okay, so the next part, would we have been less likely to commit a type 2 error in this case? Okay, so for this, you have to know the basics of errors in hypothesis testing. So before answering this question, let's go to the theoretical part of it. So, errors in hypothesis testing. The null hypothesis in real life can either be true or false. And when we are doing the hypothesis testing, it can we may either reject the null hypothesis or we may not fail to reject the null hypothesis. So in case 1, if the null hypothesis is true and if we reject the null hypothesis, then we are committing a type 1 error. Sorry. If the null hypothesis is true but we fail to reject the null hypothesis, that means we are making a correct decision. If null hypothesis is false and we fail to reject the null hypothesis, that means we are committing type 2 error and the probability is better. We'll come to alpha and beta a bit later. So in our case, in part 1, we fail to reject the null hypothesis, right? So even though mu is 232, the null is not correct and still we fail to reject the null. So that means we committed a type 2 error. Now, the last one, if null is false and we reject the nulls, that means we are doing it correct. We are reaching a correct conclusion, then we are correct in our test. There is no error in our testing. Okay, so let's look at alpha and beta a bit more rigorously. So this is, let's say we have the null hypothesis and this is the distribution of the null hypothesis, and let's assume that null hypothesis is true. Okay, if this is the distribution, the basic first concept is we can get a value anywhere under this curve on the x-axis. Okay, all right, so now the decision is, so this dotted line, this is the critical value and we are doing a right-sided test. Okay, so if we get a value on the right side of this dotted line on the x-axis, so that means in that case we will reject the null. If we get any value on the left side of this critical line, then we will fail to reject the null. Okay, now let's say the null is not true. This red one, the distribution by this red one is actually true. And the alternative hypothesis said it is greater than 225. So let's say we have a distribution like this. Okay. So now the value we will obtain can be anywhere under this red curve on the x-axis. So if we now interpolate one graph on another, one plot on another one, we get this. So now when we are doing the testing, if we are on this blue zone on this side, we'll reject the null and we will be correct. But what about we get example data from here? What happens then? We will fail to reject the null even though null is not true, right? So that means when we are in this pink shaded zone, that time we are committing a type 2 error. Null is not correct and still we are failed to reject it. So that's beta. So in this case, just as an example, in this case, the shaded area is 13.7% of the total area under the red curve. Okay, so now what happens to the beta if the distribution of null and alternatives are far apart? If they are far apart, there is no pink zone. The beta get reduced, right? Okay, so go back to this one. What happens if to the beta if we increase the sample size? So if we increase the sample size, variance get reduced, and it's as if the distribution got further apart, and again, once again, beta got reduced. So from this, I hope we have everything to answer our questions now, right? So what in this case, when the sample size is increased, would we have been less likely to commit a type 2 error? Yes, because sample size increased, variance is reduced, so as if the distributions are further apart, and then we'll be less likely to commit a type 2 error. And for the question 3, when are we less likely to commit a type 2 error if the mu is 232 or 242? 242 is farther apart than 225. So obviously, when it is 242, we are less likely to commit a type 2 error. So I hope I could make things make things understandable to you, and actually, and in the next step, we have so many things to learn: hypothesis on test of proportions, hypothesis on regression of coefficients, and many more. And hopefully, I'll get the chance to teach you all this and many more. Thank you very much.